Alright, so 1.3 is over right triangle trig. So right triangle trig is really the same trig that you learned in geometry. We're just going to go a lot further here in pre-calc. So it has to do with looking at your relationship to theta, and with relationship to theta, thinking about where the opposite side is, the adjacent, and the hypotenuse. So let's go ahead and do that for the triangle shown. So here is theta, and really, when you label the hypotenuse, it doesn't matter where theta is. The hypotenuse is always the side across the 90-degree angle. So this is the 90-degree angle, so the side across from that, this is the hypotenuse. So you can go ahead and label the hypotenuse if you want to without thinking about theta. And then for the next part, we need to say, okay, well, this is theta, and I'm left with opposite and adjacent. If I take theta and I go to the opposite side, that's right here. So this is the opposite, and this is the adjacent. So we're going to use these side relationships, opposite, adjacent, and hypotenuse, to do our trig. So we have actually 6 trig functions. We have sine, cosine, and tangent. And then we also have cosecant, secant, and cotangent. Now these 3 are probably new terms to you, and these are their respective reciprocals. So reciprocals means the flip. Top goes to bottom, bottom goes to top. So sine of theta is, let me redraw my triangle over here. So here's my triangle. Here's theta. Here's opposite. Here's adjacent. And here's the hypotenuse. So when we say sine of theta is equal to, you're saying that sine of an angle theta, so here's the angle theta, and that's going to be equal to the ratio opposite over hypotenuse. Cosine of theta is equal to, so here's theta, cosine will be equal to the ratio of the adjacent over the hypotenuse. And tangent of theta will be equal to the ratio opposite over adjacent. So there is an easy way to remember this. You've probably heard and remember SOHCAHTOA from trig or from geometry. And SOHCAHTOA said S sine of an angle is equal to opposite O over H. Cosine is equal to adjacent over hypotenuse, and tangent of an angle is equal to opposite over adjacent. So those are just the letters to help you remember these ratios. SOH, CAH, TOA. Alright, for the second part, these are the new ones. So if you can remember sine theta is equal to opposite over hypotenuse, then cosecant is his reciprocal. And what reciprocal means is you flip. Top goes to bottom and bottom goes to top. So that means instead of being opposite over hypotenuse, it's now going to be hypotenuse over opposite. Secant of theta is going to be the reciprocal of cosine. So again, top goes to bottom, bottom goes to top, so this is hypotenuse over adjacent. And then tangent of theta, his reciprocal is cotangent, and that's adjacent over opposite. So So how I remember which ones go with which is I say everybody has a co. So sine needs a cosecant. Cosine is a so he just needs his friend secant. And then tangent needs a cotangent. Alright, let's go to the next page. Okay, so we're going to, in example 1, find the values of the 6 trig functions for angle C. So since it tells us that we're going to be talking about angle C, you can go ahead and put your theta here. And if we're going to put theta there, that means go opposite is ED. Adjacent. So when you say adjacent, it's always not the hypotenuse. So this must be the adjacent, and this is the hypotenuse. If you notice when you look at this problem, we actually have real numbers to represent ED as 3 and CD as 6. So before you start, you should really get the hypotenuse value for CE. So let's go ahead and do that. And if we're going to do that, we can just use Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared, where c represents the hypotenuse. So 3 squared plus 6 squared equals c squared. So 3 squared is 9 plus 36 equals c squared. So 45 equals c squared. And we take the square root. In order to get rid of a square, you have to take the square root. So that's C. Now this is why we practiced radicals. So 45 is not reduced. 45 is 9 times 5, and if I choose 9 times 5, I can reduce it to 3 square roots of 5. So 3 square roots of 5 is the hypotenuse. Okay, so now what we're going to do is actually answer the question. We're going to find the values of the 6 trig functions. So let's start with sine. So sine, and we're talking about angle C, is equal to. And if you want to remind yourself of SOHCAHTOA, I like to write it like this so that I remember I'm talking about a ratio. SO over H, Ka, CA. But right now I'm just looking at sine. Sine of an angle is equal to O over H, opposite over hypotenuse. So here's my opposite according to what I labeled, and here's my hypotenuse. So 3 is the opposite, 3 root 5 is the hypotenuse. Now we do want to reduce this, so I see a 3 over a 3. Those will cancel with each other, giving me 1 over root 5. Not allowed to have radicals, so I'll multiply root 5 over root 5 to get me a final square root of 5 over square root of 25, which just makes 5. Alright, now we can do cosine of angle C is equal to, and now cosine is equal to the ratio A over H. So my A is 6, and my H is 3 root 5. So 6 over 3 root 5. So once again, this will reduce. 6 over 3 is 2 over 1. So this is 2. I don't really need to write that 1, so I'm just going to write square roots of 5. Rationalize it to become 2 square roots of 5 over 5. Alright, and TOA, tangent of angle C, is equal to opposite, which is 3 over adjacent, which is 6. 3 over 6 is 1/2. Alright, so those should be the ones that you're pretty familiar with. But we have to do all 6 of these trig functions. So we have 1, 2, 3 down. These are our first 3 answers. Now we got to do the other 3. So the other 3 were cosecant, secant, and cotangent. So cosecant of angle C is equal to, and now let me write this again. So TOA. So cosecant is the reciprocal of sine. So since sine is O over H, this is going to be H over O. So that's 3 root 5 over opposite, which is 3. And so this reduces down to root 5, square root of 5. You don't need to put that over 1. So I want you to take a look. If you had just from this point, if you can kind of see this, I don't know how to do this so that you can see both. But let's just take a look at sine. So sine of angle C was equal to 1 over root 5. You could have actually just taken this answer from the beginning and just flipped it, and you would have gotten root 5 over 1, which is this answer. So you could do it that way. Secant of angle C is equal to, secant is the reciprocal of cosine, so it's H over A. So H is 3 root 5, A is 6, so H is 3 root 5, A is 6, and that will reduce down to square root of 5 over 2. And finally, cotangent of angle C is equal to A over O. It's the reciprocal of tangent. So A is 6, O is 3, so that's 2 over 1, or just 2. Alright, so I'm going to go ahead and erase all this, so hopefully you've gotten this down by now. Alright, so we're going to do the same thing for example 2. Find the values of the 6 trig functions for angle A. So now angle A is my theta. Go ahead and label opposite, adjacent, and hypotenuse. So you might find it easier to start with the hypotenuse, because it's always the side across 90. So this is my hypotenuse. So go opposite of your angle. This is opposite. And AB is going to be adjacent. Kind of the same thing here. We have to do Pythagorean theorem to find the sine. Make sure when you do Pythagorean theorem, you do a squared plus b squared, let's call this b, so we don't know this, equals c squared. So 4 squared plus b squared equals 6 square roots of 2. You're going to square c squared, so you got to square that whole thing. So this is 16 plus b squared equals, so 6 squared is 36. Square root of 2 squared is 2. So that's actually 72. Subtract 16. So 6, carry the 1, so that's 56. And take the square root. So 56 is 4 times 14. So 4 times 14 makes 2 square roots of 14. Okay, so this is 2 square roots of 14. All right. Sine of angle A equals opposite, which is 2 square roots of 14 over hypotenuse, which is 6 square roots of 2. So let's see how this reduces. 2 over 6 is 1 over 3, and square root of 14 over square root of 2, 14 over 2 is 7, so that's going to make square root of 7 on top. So that actually doesn't need to be reduced anymore. Square root of 7 over 3. Cosine of angle A is equal to, so cosine is adjacent over hypotenuse, so that's 4 over 6 square roots of 2. So let's see how this one reduces. 4 over 6, 4 and 6 both divide by 2, so that's 2 over 3. And square root of 2 is still there. So we do need to rationalize this to make 2 square roots of 2 over 6. For a final answer, square root of 2 over 3. And tangent of angle A is equal to opposite, which is 2 square roots of 14, over adjacent, which is 4, so square root of 14 over 2. Alright, if we do the reciprocals. Now, this time when we do the reciprocals, let's just see if we can take the answer we got and flip it. So, the reciprocal of sine is cosecant, so cosecant of angle A. So since these guys are reciprocals from each other, if I just take this answer and put top on bottom, bottom on top, I get 3 over square root of 7. And rationalize it, so you get 3 square roots of 7 over 7. Now, secant of angle A is equal to, so now it's 3 over square roots of 2, so 3 square roots of 2 over 2. And cotangent of angle A is equal to 2 over square root of 14. So 2 square roots of 14 over 14 makes square root of 14 over 7. Alright. Alright, so on example 3, we are going to do the following problems. You might really just want to redraw the triangle each time, kind of treat these as completely separate problems from each other, so I'm just going to kind of block these off. So in example A, I'm going to redraw the triangle, and S, R, T, and so this is my angle. I'm talking about angle S, so I'm going to put my theta there. So I'm told if sine of angle S is 1/5, find SR. So if I know that sine of S is 1/5, keep in mind sine tells you sine of an angle is equal to opposite over hypotenuse. So that means that 1 is the opposite and 5 is the hypotenuse. So 1 is the opposite and 5 is the hypotenuse. And I want to find SR. So if I want to find this length, I have to do Pythagorean theorem. So 1 squared plus b squared equals 5 squared. 1 squared plus b squared equals 5 squared. So this is b squared equals 24. I skipped a few steps there. So 2 square roots of 6. So this is 2 square root of 6. Alright, let's do B. If tangent of t equals 2/3, find ST. So I can just use this triangle since I'm here. So tangent of t, so tangent of an angle is equal to opposite over adjacent, TOA, O over A. So I'm talking about which angle, so it's angle T here. So put your angle here at T, and my opposite is 2, and my adjacent is 3. I want to know ST, which is this side, the hypotenuse, which I don't have right now. So I'll have to do SOHCAHTOA again. I'm sorry, not SOHCAHTOA. I'll have to do Pythagorean theorem. So 2 squared plus 3 squared equals c squared. So that's 4 plus 9. So 13, which does not reduce. There we go. All right, cosecant of angle T is square root of 15 over 2. So let me redraw my triangle. S, R, T. I'm talking about angle T. And cosecant. So this is a little bit harder. Cosecant is the reciprocal of sine. Sine is O over H, so this must be H over O. So H is root 15. Opposite is 2. Since I want to find RT, so RT is the side that I don't know, so once again I'll have to do Pythagorean theorem. So 2 squared, so 2 squared plus b squared equals root 15 squared. So that's 4 plus b squared equals 15, so b squared is 11, square root of 11 is a final answer. Alright. And example 4. In example 4, this is a different example. We don't need that triangle anymore. So we're just saying cosecant of theta equals 5. So this time you get to pick where theta is, because it doesn't tell you like this. It told you it's in T. So I don't have any letters on a triangle that I'm making up. So just pick any theta. So I can pick this theta. Just don't pick the right angle. The right angle you don't ever talk about. You just know it's there. So cosecant of theta equals 5. So since what we're talking about here is a ratio, ratios are fractions, you really need to put 5 over 1. And again, go through the process of saying, well, cosecant, that's the reciprocal of sine. So this is h over o. So my hypotenuse is 5. My opposite is 1. So 5 squared equals 1 squared plus b squared. So we've already done this. This is square root of 24 or 2 square roots of 6. So tangent of theta is going to equal, so tangent of theta is equal to TOA, opposite over adjacent. So the opposite is 1, the adjacent is 2 root 6. Rationalize it to 1 over 2 root 6 times, I'm running out of room, so times root 6 over root 6 is root 6 over 12.